I'm going to present about the research paper which was given by Northeastern University and University of California. It is finding malicious domains using passive DNS analysis. So, what is DNS? So, as my friend said, Akhil, in the previous presentation, it is exactly the same. Like it is the hierarchical naming system for computers, resources connected to the network on the internet. So, while using this, while the people are on the right hand side, you can see the users are uh, browsing some data on internet, and you can see this is the domain. These are the ibm.com is one domain, and also 129 is IP address. So DNS plays a vital role in the operation of internet, providing a two-way mapping between domain names and numerical identifiers. So by using when the users are browsing some data, so there might be some malicious activity will be going on. So let us see the scenarios. Like, yeah, there are some scenarios like malicious code, phishing pages, spam mails, ransomware. So like downloading sites where malicious code is hosted, phishing pages that aims to steal sensitive information from unsuspecting victims. So in this paper they introduced two scenarios. One is like uh, in machines, like normally machines can be transformed into bot, like a chat bot or something like that, so which listens and react to remote commands that are that issued by so-called like bot master. So eventually they are used to launch some DOS attacks, like DOS attacks, like DOS attacks means denial of service attacks, so that they can steal some sensitive information. And while coming to second scenario, they also like introduced about phishing website. So if anyone is setting up like phishing website, it is also one kind of way to access the user's confidential data, like online banking credentials, like credit card numbers, or NPI number of a doctor's license number or something like that. So in this paper, they talked about like exposure. It is the real world data set which is collected like over many domains over a period. It takes them to collect like over a period of 2 to 3 months. The data that used for the initial training consists of DNS traffic from the Security Information Exchange that shares the real-time response data. This data has been collected from authoritative AIM servers, which are located in North America and Europe. So they also analyzed more than 100 billion DNS queries that targeted like 4.8 million distinct domain names. They were able to, and later on they were able to identify more than 3,000 new malicious domains, and even they cross-checked with like they are uh, like they want to identify they are able to find correctly or not with malicious domains like McAfee Site Advisor and Norton Safe Web. So let us see the architecture. So this is the architecture they introduced, like malicious. In this architecture, it is there are 5 components. The first one is data collector, then future attribution, malicious benign domain collector, learning module, and classifier. So let us see what exactly these components do. So data collector, uh, it is the first component of our exposure system. So data collector records DNS traffic produced by the network that is being monitored. Like many of the domains has been coming up on the browser, so it collects the data and also records the DNS traffic, and also it monitors how many requests are coming in. So like that. So when coming to the second component, it is feature attribution. This component is responsible for attributing domains that are recorded to uh, database with features. So coming to the third component is malicious or benign domain collector. So this is the as the name says that it is malicious and benign domain collector, right? So in this, it collects the domains that are no that are like benign and also malicious from various resources. So it collects and passes the output to the labeled data and unlabeled data. You can see on the right. So once the data is labeled, then the data is passed to the learning module. Okay, learning module, and this module trains domains and set to detect domains like after the domains are has been labeled, then finally it passes to a classifier, and this classifier like classifies whether the domain is malicious or benign or something like that. So coming to the feature selection, in this feature selection there are four feature sets. So the first one is time based features, and the second one is DNS answer based features, and TTL value based features, domain name based features. So as the name says, yeah, as the name says, time-based features. So the time-based feature, it is the first component of DNS record. Like uh, it it is like when the DNS has like domain request has been occurred on the internet, then the time when it has been occurred, like it records the time like when the DNS request has been made. They also introduced depending upon this, they also introduced like two concepts. One is like domain flux and another is DGA. So domain flux normally it is a technique that monitors the fluctuations of request on internet service provider, and whereas the second one, DGA, it is a domain generation algorithm. It is abbreviated as like that. So which is used to calculate the list of domains to be used as command and control servers. So to analyze these changes in the number of requests of DNS queries, uh, they actually for a given period of time, they divided this period into time period into fixed length of interval. Then for each interval, they count the number of DNS queries that are issued for the domain. So coming to the last point, which is short-lived domain. So the short-lived domain is like that, like the domain which is queried only in between some certain time interval. Like let us suppose the domain has been like queried at time t0 and lost the signal or something like that at time t1. So the time span between t0 and t1, this is known as like it occurs in certain span of time. So then they told it as like short-lived domain. So coming to the like they also introduced the formula for calculating the distance between two similarities of domain, like yeah, one second. Yeah, it is d equal to dij n minus 1 into n minus 2 by 2. So in this, like assuming that a domain has been queried n days during our analysis period or something, dij, here dij is the Euclidean distance, and dij is a Euclidean distance, and it is calculated by the average of n minus 1 and n minus 2 by 2. So by calculating this, we can get the similarity between like distance between the two similarities of domains. So coming to the next feature set, which is DNS answer based features. In this, uh, the DNS answer that is returned by the server for a domain generally consists of several DNS records. They also extracted some good features from this feature sets. Like the first feature is the number of different IP address that are resolved for a given domain during while they are doing something like experiment or something like that. The second feature is number of different countries that these IP addresses are located in, where the IP address are located in which country or something like that. And also the finally they also extracted the good feature, which is reverse DNS query results of the return IP address. And coming to TTL value based features. So TTL value based feature, actually TTL is abbreviated as time to live. So every DNS record has a time to live that specifies how long the corresponding response for a domain should be cached. It is it is actually recommended that the TTL is set to between like 1 and 5 days, so that both the DNS clients and name servers can benefit from the effects of DNS caching. So the next one is domain name based features. So as in the name, we can see that domain name based. So what we can understand from that is these features are based on the domain. So like nowadays you can see the good companies benign services which are legitimated as domains, so they use or they choose the domain names that can be easily remembered by the users. Like for example, you are seeing on my screen that it is www.icelandbank.com. So Iceland Bank, a bank itself, has taken its own name, and it has been like it uses its own domain. Like we are from University of New Haven, so our university has its own domain like www.universityofnewhaven.com. So in like contradiction to it, the attacker could not be like easily get into this type of domain. So he doesn't know the exact uh, name of our domain, so he can't be like he can't enter into certain types of domains. So uh, they like coming to the building detection model. So they use the classifier. First they compare all domains in benign domain list with the malicious domain list, and with the tools they test domains for their maliciousness. They specifically used McAfee and also Norton Safe Web. They also able to find like more than 3000 domains, like 3000 domains they detected. And also they use some classifier known as which is built as J48 decision tree algorithm. It is an implementation of C4.5 algorithm. It is designed for generating either pruned or unpruned decision trees. So actually it constructs a decision tree from a set of labeled training set by using the concept of information entropy, like the attribute values of training set, you can say. The G48 algorithm splits into smaller subtrees with the information obtained by the attribute values. So whenever the algorithm encounters a set of items that can clearly be separated from other class by a specific attribute, like it is a malicious or benign, so it branches out a new leaf according to the value of attribute. So each time a decision needs to be taken, the attribute with the highest normalized gain is chosen. So among all uh, possible values of attributes, if there is any value for which there is no ambiguity or something like that, the branch is terminated and the appropriate label is assigned to it. The splitting procedure stop when all instances in subsets belongs to the same class. Okay, so while evaluation of classifier, they did some type of combinations you can see on the right. So these are the combinations, like they took full set. Actually, they took first initially they took the full data set. Then after that they did tenfold cross validation. If there are like cross validation is like this, like resampling procedure. Resampling. It is a resampling procedure used to evaluate machine learning models on a limited data sample, and also it takes the parameter k. So here k value is 10, so you can say it is 10-fold cross validation. Okay, so the next one is like 66% training data set. So to find the combinations of features that produce the minimum error rate. So you can see the graph between error rate and the feature sets. So in this, the 10-fold cross validation, 66% percentage split, and training on whole training set, the smallest error rates were produced by F1. Okay, here it is F1. Therefore, while experimenting with different combinations of feature sets, they excluded the combinations do not include F1. However, when all features are combined, the minimum rate is produced. Hence, the combination of all features, and you can see here the future F4 has the higher error rate, which is 20%, and the lowest is when the all the combinations has been taken. So it is at most like 0 to 1% to 2%, I guess. Yeah. So they also introduced some metrics, like full data. Well, considering the full data in the area under curve, they got like 0.99, and 10-fold cross validation 98%, you can say. For 66% of percentage split, they got 98%. So they also consider the false positives, like 0.3, 0.9, 1.1. So they got the values. Oh, sorry. So this is the time span for detecting malicious domains. Like before they got like uh, when the domain requests are coming on during these days. So actually initially they got domain count more than 600 to 650. Then later on it goes on decreases. So after they collected the data from those domains, the time taken for them is like very less, I guess. But the thing is like in between 6 to 8, they detected more than 16, up to 1600 domains. So in between 6 to 8 days they detected like 1600 domains. So this is the first time, the first time a domain is queried and it is detected. So while coming to the conclusion, the domain name service is a crucial component of the internet, and they introduced the exposure, which is I think it is a good system which employs the techniques to detect malicious domains, and also it can help for like security experts and also good organizations which contains like confidential data like doctor's office or USICS. It contains our confidential data also. So like that. So it can also help for them to fight against the cybercrime. uh, and at last they also mentioned that they plan to release this exposure system to the public as a community service. Okay, thank you.
Well, thank you very much. This was an excellent presentation.
Thank you. Thanks.
And it actually brings up a lot of questions and a lot of ideas. I'm going to start with one of those questions. The type of classifier, the type of machine learning model that the authors implement and train to detect malicious and benign DNS traffic or domains is supervised.
Yeah.
So, where do they get the labels from?
So actually, in data set itself, I think they didn't mention the like. They also told like in the architecture, there is some components they already. One second. Okay. So actually, after getting the normally many domains, so after that they are classifying this they are labeling that whether the domains are benign or not, and then after they are passing through the learning model. After that learning model, they are passing through a classifier.
Right, right.
Yeah,
So to be more accurate, what they do is for the offline data set, they
yeah,
manually investigated 50 random malicious domains from their list of 17,686.
yeah,
And
exactly.
they mentioned that among the 50 randomly chosen domains, the classifier detected 3 benign domains as malicious. So out of thousands and thousands of domain names, they only investigated 50. As for the second experiment, which was for real-time detection, they resorted to some heuristics for labeling, such as the Alexa score. Is anyone here familiar with Alexa? Not the Amazon chatbot, but the ranking system.
Yep.
Let me
Okay.
see if anyone has their hands up. If you know what Alexa is, put your hands up.
Uh, I know what Alexa is.
All right, can you tell us what Alexa is?
Alexa basically ranks your web addresses based on the number of backlinks and the credibility. Uh, you can say Facebook, Google.com, Facebook.com, Microsoft.com would be in the top 10 of the Alexa ranking system, like Wikipedia. So the lower the ranking in the Alexa system, the less credible the website is.
Yes. Well, the less credible it seems, or there's a lower probability for the website to be credible. Uh, However, these are just heuristics. These are not accurate labels. There are many, many spamming domains or scam websites that have a higher Alexa score than my personal website, right? So the accuracy or the exactness of the results reported in this study is a little doubtful, but
Yeah,
it's still useful. It's still very useful. Why?
yes,
Because in security data science, we often have to deal with unlabeled data. We have to deal with large data sets, many, many thousands of data points or millions of data points that do not have labels. And it's very costly to do manual labeling, to manually label those data points. So resorting to such heuristics, such as Alexa score or McAfee Site Advisor score or the output of these are relatively old, but Norton Safe Web and Google Safe Browsing, these can help with some initial or some estimated approximate approach to labeling. So with that in mind, we have to take the results with a grain of salt, especially the results that have to do with false positives and false negatives,
yes,
because the authors do not really know what the count of positive and negative samples is. They just have an estimate. And there's a very good chance that their approach to estimating the labels is obsolete and cannot apply to domain names of today. Um, Before I move on to the next seed question, does anybody have any thoughts, comments on this? All right. Now, I want to ask you all, including Afshar,
yes,
to suggest a different feature than those extracted and studied and used in training the model presented in this paper. If you personally were to analyze domain name and DNS traffic to see whether it's malicious or not, what are some of the things that you would pay attention to?
I think if I do it, then I will be uh, getting a list of famous companies on which users do attacks, like Facebook. And if the Facebook word is present in the domain, but it is not exactly facebook.com, it's like facebooklogin.com or something, then I'm going to add it as a bad domain or a phishing domain, and similarly for all other domains. So such domains can be malicious.
That's an excellent idea. That's a very good idea. Let's think about Amazon. There are so many different domains, including the word Amazon. And interestingly, the vast majority of those domains are legitimate. They all correspond to some part of the server infrastructure of Amazon and Amazon AWS. The same holds true with Facebook, not just Facebook, but FB dash something may be representative of a legitimate service or a legitimate DNS mapping to a benign server in Facebook. So would it be possible for us to come up with accurate blacklists based on this heuristic? Ali, do you have any thoughts on that?
Only based on this list would be not be possible, but we can combine it with other things like certificate validations. A good domain will have a good certificate signed by a good authority, not a free certificate like thing. So we can combine them to get a list.
Exactly. That's a very good
Yeah, that's
idea.
good. That's good.
Yes. There's something going on in chat. So Sai has an idea she would like to share with us. Sai, can you share your idea with the class via audio?
Hello again. I was just going to say that in order to do what you were saying, a baseline of good domains or known acceptable domains, such as the ones that say Amazon dot something or FB dot something that are legitimate, would have to have a known list to then identify ones that are very similar but not necessarily accurate or real domains.
And coming up with that white list is not an easy task, especially considering new domains, new legitimate domains that are being registered every day for startups, for personal websites, for educational websites, for NGOs. There are many, many new domains coming out that can be legitimate. And if you want to maintain a whitelist of legitimate domains, it's going to be a very difficult data collection, analysis, and curation task. But it's surprisingly still one of the main approaches taken by many of the security monitoring companies. So whitelisting and blacklisting is still heavily used in security data science. What else? What other feature can we look into?
We can check if the domains are pointed towards blacklisted IP addresses.
Sure. Yes. So using threat intelligence feeds to come up with an up-to-date list of bad IP addresses and see whether those domains are affiliated with those IP addresses or not. But what would this affiliation look like? What should we consider to be a strong and indicative affiliation? Is it just having the same IP address? Is it being in the same subnet? Is it being in the same autonomous system?
I think same IP address, because in same subnet, like if your website is hosted on DigitalOcean or AWS, then the same subnet will be used by many other credible websites.
Yes, that's a good idea. But another thing that in an ideal world, in utopia, would be possible would be to study the interactions and the level of interactions between different IP addresses. So if you're sitting at the headquarters of an autonomous system is 2 layers above your local ISP. It essentially moderates a large network, a very, very large part of the internet. If you're sitting there and you have access to raw traffic, you may be able to analyze the strength of contextual and actual observed interactions between different IP addresses. And you may be able to apply unsupervised learning to do community detection and figure out whether certain IP addresses are part of the same community or not. This is just at the level of idea. This just came to my mind. There's a very good chance that somebody somewhere else has done some studies on this and has published papers on this, but paying attention to IP addresses and checking against blacklists is a really good idea. What about the language structure of the domain name? Can we use this feature or informations related to the syntactical and grammatical aspects of domain names to figure out whether a particular domain name is malicious or not? Like if a domain name is xy21z22.ru, would you trust it at the first glance?
Nope.
But here's the thing, XYZ is a legitimate company.
Yes.
So coming up with good grammatical rules or a grammatical feature representation or a syntactical feature representation of domain names may actually prove to be not so useful. However, combined with other features, it can help with enhancing the accuracy of both feature representation and the classification task. So any other thoughts, any other ideas, any comments? Very well. Afshar, thank you so very much.
Again, thank you, Professor, for giving me this good opportunity.
Thank you.